Hello everyone. Today I would like to share our research about the seismic velocity changes associated with the 2019 Ridgecrest earthquake sequence. The Ridgecrest main shock is the largest one in the past 20 years and occurred 34 hours after the 6.4 foreshock. The sequence generated surface rupture and triggered widespread seismicity. We focus on the fault area and the coastal geothermal field in two aspects: co-seismic velocity changes and the post-seismic healing process. Both are helpful to understand the stress change, the fault damage, and the recovery process. We use the continuous records from 2018 to 2020 from 22 seismic stations, majority of which are located within 50 kilometers from the sequence. By using the ambient seismic noise interferometry, we captured a sudden velocity decrease in the fault area and the coastal geothermal field. A sudden velocity decrease in a frequency range of 0.1 to 0.9 Hz is observed in the rupture area following the 7.1 earthquake. Velocity began to recover in early August. Co-seismic velocity decrease appears vertically pass through the rupture area, achieve 0.5%, and parallelly once achieve about 0.4%. Pairs outside but parallel to the rupture area show a lower decrease of about 0.25%. In the coastal geothermal field, velocity changes and is not so large as the rupture area and accomplished with fluctuation. This is related to fluid activity. Based on these velocity changes, we employ an inversion to characteristic post-seismic recovery process. The characteristic recovery time of station pairs is found to range from about 40 days to about 10 years. Then we can split the static part and the dynamic part from the co-seismic velocity changes of each station. We found that stations located near the end of 7.1 rupture area show larger static velocity changes than other stations. That makes sense, because end of the rupture always suffer severe damage. Based on the ratio of peak ground velocity from the 6.4 and 7.1 event, we calculated the dynamic co-seismic DVV changes due to the two earthquakes. Results suggest that, except the station LRL, located at the end of 6.4 event rupture, dynamic DVV of stations induced by the 7.1 event are larger than that of 6.4 event. For the 6.4 and 7.1 events, we respectively made use of their PGV measurement to estimate the effect of dynamic stress changes imparted by them. The dynamic peak strain was estimated by dividing PGV by the local shear wave velocity at individual sites. The level of station dynamic DVV appears to correlate with the dynamic peak strain, except for few stations. We will continue to study in depth. That's all. Thank you so much for the attention.